Hello everyone. In today's video, we will try to understand concepts of the volume in the Kubernetes. First of all, let us try to understand why do we need the volumes. So, Kubernetes in all the containerized applications, let's say Docker container or Kubernetes pods. In Kubernetes, we call it the pods, and in the Docker, we call it the running application is called the containers. So, in all the containerized applications, the the pods or containers are ephemerals. What I mean is when those pods are generating data, these data will be staying inside the container, maybe application log or maybe generating some creating some files. Those data will be staying inside the containers, and container cannot directly interact with the file system. It does not have the visibility of the file system. That is why the data cannot be directly stored on the file systems. That is why there is a concept of the volume being introduced, so that volumes will take care of storing data on the external systems. So to understand it better, it is important to understand the architecture of the Kubernetes. In the Kubernetes, what happens is there is a master node. Master node may be residing inside the you know EKS cluster or something, and then it will be attached with a multiple worker node. It may be one worker node, it can be multiple, it can go up to 10, 15 or something. And each worker node you can consider think of it like a virtual machine. So if there are two worker node being attached with a master node, so when we are deploying that container, we may not be knowing where the container will start. It may start on the worker node 1 or it may start on the worker node 2. And again, if we are creating a new volume, it may be stored inside the worker node 2, and the pod that is deployed on the worker node 1 want to access that data defined in the volume. So that is why it is important that volumes concepts to understanding volume concept in the Kubernetes is very important. So if we think at core, volume is a directory with some data and pod wants to access that data. We also have a concept of volumes in the Docker, but in a Kubernetes, concept of the volumes is much more mature and powerful. So in a Kubernetes pod, multiple volumes can be attached simultaneously with the pod. We can have AWS S3 volume, we can have Azure storage volumes, and both can be attached with the simultaneously attached with the one pod. Mainly, there are two categories of the volumes in the Kubernetes. One is ephemeral volumes, and which has got a lifetime of the pod. That means when we are deleting the pod, that volume attached with the pod will be removed from the Kubernetes. And another is the persistent volumes. The persistent volume is a newer concept in the Kubernetes, and the life cycle of the persistent volumes are separate from the life cycle of the pods. So both can simultaneously have a separate life cycle, and the life cycle of the volumes will not get affected with the life cycle of the pods. For example, if we delete the pod, then it will not affect persistent volumes. So let us try to understand concepts of the ephemeral volumes. We have a concept of anonymous volume in a Docker. containers. So these ephemeral volumes are somewhat similar to the anonymous volumes in a Docker containers. So ephemeral volumes, if we try to understand the properties of the ephemeral volumes, their lifetime is attached with a pod. So when we create the pod, this volume will be attached with the pod, and when we delete the container, this volume will be deleted. Some applications, some application we can think of like caching applications, where we want to store some data at runtime, and when the application is stopped, we want to remove that data. In this case, we can use the ephemeral volumes. Also, some of the applications we can think of like secret keys or config data or something. We want to generate that data, and as soon as the application dies, we also want to delete that data as well. Some of the examples of the ephemeral volumes are empty dir, then config map, or there are like the drivers available. So this is like container storage interface CSI ephemeral volumes, and there is also like generic ephemeral volumes. So there are many different kind of ephemeral volumes available in a Kubernetes. Many volumes used in a Kubernetes are created with the help of the persistent volume subsystem. So that is why it is important to understand how the persistent volumes and persistent volume claims are created and used in the pod. So PV, persistent volume subsystem API, that extracts the detail of how storage is provided from how it is consumed. So this uses mainly two type of API resources. One is persistent volumes, and another is a persistent volume claim APIs. So persistent volume are a kind of a plugin, has a independent life cycles just like a pod. So it can be created separately, and it can be consumed by the persistent volume claim separately, and it uses the resources to create the persistent volume. It uses the resources of the storage like Azure or AWS S3 or Google Cloud Storage or something. These storage or file system, virtual machine file system storage, it can use to consume that. And persistent volume claim is a request for the storage by the user. So this is creating the request, and that will be using the resources of the persistent volumes. If we try to compare that with the pods, so what does the pod do? Pod consumes the node resources, like it requests for resources, like request for the pod, request for the CPU and memory resources. Similarly, persistent volume claim consumes the PV resources, persistent volume resources, and it will request for the specific size and also the access mode like read only, read write, or some other type of access mode. If we try to understand with the diagram, persistent volume will be consuming the resources of the storage, right? And persistent volume claim act as a bridge between container and persistent volume. So when we create the persistent volume claim, these claim will be attached with the containers, and these containers will ask for the resources. So data, whenever we store the data using the persistent volume, the data will be stored on the storage system. Also, if you try to understand, uh, I have created only one persistent volume claim, but this persistent volume claim is attached with the multiple containers. and this persistent volume claim is attached with the persistent volume. In the coming videos, we will be exploring more about how these persistent volume claims, and deployment objects are created. But this is just trying to make you understand how the persistent volumes, persistent volume claims, and the deployment objects are interlinked. So if you look at it, the persistent volumes is created on the left side. It uses the storage. In our case, it is using the file system storage, and it is requesting for the 1 GB of the data, and the host path defined is somewhere on the file system. In this case, I am using the Windows file system, and then I have defined, if you look at below the persistent volumes, I have created a persistent volume claim. And this persistent volume claim is using the name of the persistent volume. And also in the persistent volume claim also you can define the storage. Here this storage can be maximum as the at max we can have the volume requested by the persistent volumes, or it can be lower than that. And once I create the persistent volume claim, I can attach that persistent volume claim with the containers, the pod that I am creating. And this pod will use the, ultimately it will use the whatever the volumes that is attached with the persistent volume. Earlier what used to happen is, if you wish to use any specific cloud provider storage, then you have to go through their implementation and then use their inside your persistent volume and persistent volume claim. But with the introduction of the CSI drivers, this is container storage interface, it has provided you the abstraction, the interface for how you interact with the resources. So whichever the storage providers are available, for example Azure storage or AWS S3 or Google Cloud, they are creating the CSI drivers. So now the abstraction is already there. So implementation of the persistent volume and the persistent volume claims become much more easier. The list of CSI drivers, you can find the details of all the CSI drivers at these links, and also the instruction for how to install the drivers is also provided. So this is all about the Kubernetes volumes, and in coming videos we will explore more with the help of the example. Thank you very much for watching this video.